I'm here from Tri-State Biodiesel. We're a company that was based, as Dan said, founded here in 2006. We're based in New York City, several different boroughs, and where our main operation is to recycle used cooking oil, and we take that and purify it and then convert it into diesel fuel, which is referred to as biodiesel. Biodiesel is a diesel fuel. It's another type of diesel fuel, and that's what I'll get into and explain the difference between that and diesel fuel as we know it, petroleum-based. Biodiesel was first synthesized in 1853 with the combination of different catalysts mixed with different vegetable oils, which resulted in a diesel sort of lighter oil with no glycerin or waxes in it. It can be produced with, from all kinds of different seed oils, including hemp and pennycress, jatropha, and even animal fats and tallows. The process that it goes through is called transesterification, and what that does is it pulls out, again, the glycerin, which is a byproduct that can be used to make soaps, and it has a lot of different applications, and it's very innocuous. Both products, the result, biodiesel and glycerin, are completely biodegradable and non-toxic. Biodiesel can be made from many different oil, seed, and animal products. This is a rundown here of some of the most widely used across the world oilseed plants. Now the diesel in biodiesel, that was actually a person named Rudolf Diesel who initially invented the diesel engine. A little bit of history about diesel to begin with. Everything that we do, everything that we eat, everything that we wear here in America and around the world is either brought to us or facilitated by some kind of engine that runs on diesel fuel. Now the reason why the diesel fuel is called diesel is because the man who invented the engine which burns that fuel was this guy named Rudolf Diesel, a real genius at the beginning of the industrial age. He sort of opened up the dawn of the industrial age when he created the first internal combustion engine. This guy was a real controversial figure. He had a lot of idealistic ideas around creating machines that could help people live in rural areas and far out areas and decentralized locations. He first presented the original internal combustion engine in Paris in 1898, which ran on peanut oil. And the same engine was run on many different kinds of oils, but the most accessible thing that he had at that time was vegetable oils. This is a picture of the prototype here. Now, the engine stood as an example of his vision. He hoped that it could, as I said, be something that could help people in not only the colonies, as he referred to them, which would be America, different tropical regions, areas where Europeans were going out and setting up their colonies. This is a couple quotes here I have from him, which I won't read, but leave them up there for a second so people can get an idea of what he was about. Basically here we're talking about looking towards renewable sources that are produced from the heat of the sun rather than looking towards what we can dig up from the ground and what we can synthesize. Rudolf Diesel disappeared, unfortunately, at a certain point. There's a lot of stories around how that happened, but the most compelling and probable reasons why he disappeared was because he was really interested in offering the world a substitute that was renewable and, again, decentralized. And it was at the moment that the petroleum industry was becoming bigger, and there was a push at that point to centralize people's subsistence and dependency on fuel sources rather than give people the opportunity to take care of themselves. Petroleum fuels, here's a picture of extraction. The viability of energy sources available at this time, and since the inception of internal combustion engines and the industrial age, were seen as something that would be better contained to pursue the kind of dominant paradigm of many different social structures, which we would refer to as an extractive society, where small groups of wealthy people control power and resources rather than distributing or having the distribution of wealth and control be distributed amongst the population, which recent studies have found is the kind of the source of the downfall of a lot of our greater civilizations over the history of time. Biodiesel production is a decentralized energy source, benefits all sectors. This is a couple shots of actual biodiesel feed crops. We have on the left rapeseed fields, on the right we have soybean, and the finished product here up on in the bottles there, very clean source. The Biodiesel Advantage, EPA, the EPA recently designated biodiesel as the first advanced biofuel to market. It's the lowest price light oil option currently, and in New York State we have a lot of state incentives which help to bring the price even lower. It's a very high quality fuel with superior solvent, lubricity, and cetane qualities. What that means is that the cetane is basically like an octane equivalent for diesel fuel. The octane being the power of a gasoline. Cetane is the actual power output quality of the diesel fuel. And it also has the lowest emissions per BTU of any fuel available for heat and transportation. Biodiesel can be used for both, as I said, heating and transportation in any type of blend mixed with diesel fuel from 1% up to 99% or pure, which we'll call B100. Now the terminology with biodiesel is B and then a number. The number stands for the percentage of biodiesel in the blend of the fuel. The other percentage being diesel fuel, actually. Diesel fuel is really heating oil. It's also what we use for trucks, larger vehicles, and so on in the United States. Diesel fuel is often more used across the board in other continents. For example, Asia and Europe. They run regular passenger cars and most vehicles on diesel fuel, whereas here in the United States we're more looking at smaller vehicles being run by gasoline. But here in the States, it's not a lot of people realize that it's actually diesel fuel that's heating our buildings. When we refer to number 6 oil, number 2 oil, number 4 oil, those are actually different grades of a distillate from crude oil. Now these are a few bullet points here as to what are the benefits from biodiesel. It's a homegrown source. It creates a lot of green and safe, stable jobs here domestically. It keeps our U.S. energy dollars in the country, and we see no overextension of military resources to protect that. It's a reliable fuel. It's safe. There's a much higher flash point than gasoline, or even diesel fuel. It's biodegradable, as I said, and as we move forward with more widely publicized information about biodiesel, more original equipment manufacturers, that's what OEM stands for, are accepting that biodiesel can be used in many different applications. B100 is what we refer to as pure biodiesel. This is a picture here of a boiler from the Brookhaven National Lab. Brookhaven National Labs out in Long Island have been working tirelessly for about a decade on studying what is the best way to set up a boiler system for a building to accept biodiesel in many different blends, and they've come to the point where they've basically accepted that biodiesel in its pure form is just as usable and applicable as any kind of pure distillate, petroleum, diesel, heating oil in any kind of different blend. Now here we have a few different challenges and opportunities outlined by using B100 for heat. A couple challenges are the storage and the handling. The storage of biodiesel is only a challenge in lower temperatures depending on the source of the biodiesel, whether it be from animal or from a different kind of seed crop. Tallow-based biodiesel will gel at a higher temperature, so it's really more suitable for warmer climates. The type of biodiesel that we're talking about here in the city is more based on either recycled cooking oil or biodiesel that's feedstock based from soybeans or canolas, which have a much lower gel point. So there's a much more feasible application here in colder climates for that and other sort of feedstock plant oil seeds that I'll get into later on. The challenges include slight boiler modifications and low equipment costs, but there are some equipment costs in order to set up a building to accept biodiesel, but they're much lower than gas costs. The opportunities obviously are that it's a renewable fuel. It's something that we can grow crops of every year. This is one example here of a fuel pump that one can use on a residential level. As it states here, it's something that costs about $100 or less to install and to purchase. And basically what sets this pump apart from regular fuel pumps is that the seal inside it is a Viton seal. It's a modern rubber seal which is much more resistant to solvents and fuels in general, diesel fuel included, than older rubber components. And that's basically the weakest link in any boiler system, would be a seal in a pump. This is an example of a building here in Brooklyn that's running on 100% biodiesel now. We're looking at a 5,000 gallon tank with the boiler, and it's a very large multifamily building. This building here just accepts B100 pure. We dump it right in the tank. They've experienced no setbacks whatsoever, including filter changes. Now, a filter change would be the first and foremost problem one could expect from putting biodiesel into their heating oil system. Because of the solvent nature of biodiesel, it does clean up the residue and the sludge that's left over from diesel, and it will take that and deposit it in the filter. So a lot of times what you see when you switch over to biodiesel is a boiler shutdown due to the clogging of the filter that's been picking up, the biodiesel has been picking up and dissolving that old sludge and sticking it in the filter. And we found with most buildings that we have, about 1 in 10 that we service actually have a shutdown due to a filter clog, which can be remedied right away with a filter change and then and a refire of the boiler, and it starts right back up. And basically it's about a 15-minute, $10 scenario. This is a commercial building in the Bronx that has, again, another 5,000 gallon boiler. And it's another example of a building that took pure biodiesel. Here we have a 48 unit complex in New Jersey running on pure biodiesel again. This is a picture of boiler components that are very clean. Many health benefits of biodiesel. Here in New York, we have the highest rate of asthma in the country. This is a drop-down chart of B100 emissions versus B20 emissions. The top of the drop-down is the baseline diesel emissions, and then you see the reductions in sulfur and unburned hydrocarbons and carbon monoxide, particulate matter in the yellow, and then the green represents the 20%. There's a massive carbon reduction with biodiesel. We're looking at up to 17.3 pounds per gallon as compared to diesel fuel. Anti-biodiesel hysteria is not supported by science. There's a lot of studies that have been done by the Department of Energy, the USDA, that have resulted in results like this, where we see that gasoline has the highest carbon emissions on the top, CNG and LPG being the next two. B100 is the best. Biodiesel is not to be confused with biofuels, which are always receive a lot of bad press with regard to land use. The main source of biodiesel across the country is the soybean, which is only about 20% oil. The rest of it is food, which is used for food. Land use for biodiesel has land use for crops to create biodiesel has stayed steady, while the production of biodiesel and across the board has gone up dramatically in the last 10 years. And here's a quick land use chart. There's a bunch of information here that I don't have time to get into at this point that I'd be happy to go over with anybody that's interested after the discussion. There's a couple incentives for biodiesel from the state that are very attractive. If you were to switch to even a B20 blend, the state is giving back 20 cents per gallon for either B20 or B100. And this is something you get back with your state tax return. Here we have a picture of our founder, Brent Baker, with the mayor when they signed into law the 2% biodiesel mandate, which will take place this fall. It creates basically a 20 million gallon per year market, and we hope that this will get up to more to 10 to 20%. Scaling up as we go forward, we have many different crops, sources of biodiesel production. So there's a lot of options here besides just soy and just recycled cooking oil. It's a quick shot at what's used actually to produce biodiesel. We have soybean oil being the most, animal fats being about a quarter of it, yellow grease, which is waste cooking oil, is about 6% currently. Many options for, again, biodiesel production. Pennycress is a rotating crop which you can use off-season through the winter, which continues to produce fuel. Camelina is another one. Great studies have been done on this as a jet fuel replacement, which is essentially diesel fuel. And again, crop rotation and responsible agriculture would lead to a great future in scaling up in the use of biodiesel as a direct diesel replacement in the future. And it's something we really look forward to as a replacement for diesel as we phase out other fuels through different practices such as responsible agriculture and efficiency. Thank you very much.